Okay, how are you everybody who is joined in this class? I would like to take this opportunity to welcome you into our interesting departments of electronics engineering, where that we are training a number of modules, and one of the modules is called the instrumentations, electronics measuring, instrumentation and measurements. Very interesting module, and we are in chapter 2 that's called electronics measuring and testing instruments. And then we are heading to lecture 1, that electronics measuring and testing instruments. It's a very interesting topic because you are going to be exposed to its different electronics measuring and testing instrument. In the first topic, we are actually introducing you about the measurement parameters or just instrumentation parameters. And then we've been discussing about how you can read the user manual of electronics measuring instrument. So in this topic, we are going to, first of all, I'm going to define the meaning of the term. And then after that, I will list almost 15 common measuring instruments in electronics. And then we are going to discuss them in brief, and later on, maybe we may get into too much details. So I would like to ask you that to join us into this class. How are you, electrical engineering students? Okay, are you ready for lecture 1? Well, so let us go into the business. We don't have a quick review because this is the new topic, so we are going straight forward to the part of introduction, and then we'll get into detail. So we have a first questions. This is the first question. And the first questions would like to understand the terminology. What is electronics? What is electronics measuring? What is electronics measuring instruments? Okay? What's the electronics measuring instruments? Class A, electronics measuring instruments. Well, so electronics measuring instruments, these are devices. We discussed about devices. We discussed about equipments. Are devices used to measure. So these are the devices used to measure, different or various different or various physical quantities. Different or various physical quantities. Different or various physical quantities in electronics system, or in electronic circuit, or in electronics and what in electronics components, and the electronics and the components. So this is the one of the definition about electronics measuring instruments. So these are devices. Say devices. Used to do what? To measure. To measure what? Different or various physical quantities. in electronic system or circuit and components. When you say electronic systems, we also present the electrical system, because all electronic systems, or most of electronic systems, are electrical system, because the physical quantities that we're discussing, we call them electrical physical quantities. We don't have electronic physical quantity. You're welcome. We don't have electronic physical quantity. We have electrical physical quantities. So when you say system, for instance, that we may have a particular system, such as maybe electric lift or maybe a radio. A radio is a system. It's a collection of the different systems. So in case that maybe you're interested to know about the voltage, maybe at a particular point of the radio, then you have to use measuring instruments. When you talk about circuit, it may be a small circuit, just a small audio amplifier. So in case that maybe you want to know the amounts of the current consumed by the audio amplifier when it's amplifying the signal, then you need to have measuring instruments. When you talk about components, just like a resistor, some measuring instruments we use to measure the physical quantities across the electronic components, such as resistor, inductor, capacitor, diodes, mention others, transistor, others, thyristor, what ohmmeter, MOSFET, another electronics components, amplifier, logic gates, etc., etc. Okay. Then these instruments, why do we have these instruments? So you say that these measuring instruments help engineers and technicians to analyze, we have circuit analysis, to test and troubleshoot. So these instruments help engineers and technicians to analyze or to test or troubleshoot electronics and electrical system. Okay, electrical system, by providing accurate reading, electrical system by providing accurate reading of electrical properties, such as voltage, current, such as resistance, such as frequency, etc., etc. So we say that these measuring instruments are very important, so help engineers, just like you as engineering students, and also help technicians in industries or in academic places to analyze or to test or troubleshoot electronics and electrical system by providing accurate readings of electrical properties, such as voltage, current, resistance, capacitance, inductance, etc., etc., etc. So remember that I told you engineering, including electrical engineering, is all about numbers. And those numbers, in case of electrical system and electronic system, we find them by measurement. Are we together? Are we together? Yes. Yeah. So that's the importance of this subject. So we say that there are 10 electronics measuring instruments. There are so many electronics measuring instruments in the world. So you say the following are common electronics or we call them sometimes electrical measuring instruments. Electrical measuring what? Instrument. The first one is this. So separating when I'm going to list these measuring instruments is very important for you to make a follow. The first one, so we mention these measuring instruments according to how they exist physically. Listen. Some of these, listen, attention please, stop writing. Some of these electronics measuring instruments are integrated instruments. Means one instrument consists a number of the measuring instruments. So when I'm going to mention them, I'm going to mention them according to how they exist physically. I think it's not clear. For instance, let me mention the first one. So one of the existing measuring instruments nowadays is multimeter. Say multimeter. But we've seen in electronics workshop, that multimeter consists a number of measuring instruments, such as DC voltmeter, DC ammeter, AC voltmeter, AC ammeter, diode tester, transistor tester, frequency meter, capacitance meter, etc., 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 ohmmeter, and the continuity tester, etc., etc., etc. Okay? But we mention multimeter. We don't mention those the measuring instruments found in multimeter. Are we together, class? Koja nielezee kwa Kiswahili. Nasema hivi, hapa tunavotaja hivi vifaa tunavitaja kulingana na kinavyo exist. Yaani kama hicho kifaa ukienda dukani utakipata. Nyakati za nyuma voltmeter ilikuwa iko peke yake, ammeter ilikuwa iko peke yake, ohmmeter ilikuwa iko peke yake. Lakini sasa hivi ukienda dukani huwezi kupata ohmmeter, huwezi kupata voltmeter, zimeshapotea, zimesha phased out. Okay? Lakini ukienda ukisema nataka multimeter, maana yake multimeter ndani yake utapata vifaa vingine ndani yake. Kwa hiyo multimeter ina exist. Ohmmeter ni kifaa lakini mara nyingi siku hizi hai exist. Sasa ni vizuri nikakupa hii tahadhari kwa sababu wakati mwingine nikwambia taja measuring instrument unaanza kumtajia voltmeter, hazipo hizo. Are we together? Yes. Class, is it clear? Yes. So the first one is multimeter. Say multimeter. Again, say multimeter. Okay, that's the first measuring instrument. The second one is called the power supply. Say power, and you saw the multimeter. We have different types of multimeter with different physical size and different ability to measure the electric quantities. Say power supply. So you have a power supply, and when you talk about power supply, we don't mean about linear and the switched mode power supply. No, this is the power supply. We'll discuss in short about what is the use of the power supply, but in workshop I showed you the analog power supply, the one which was heavy. Okay? Then the second one is called the signal or functional or functionality generator. Say signal or function generator. And you've seen it. Then the first common measuring instrument that we have in electronics, and it's very important, is called the oscilloscope. Oscilloscope. Say oscilloscope. The next important measuring instrument that we have in electronics is called the LCR meter. This is the electric measuring instrument. Say LCR meter. How many of you have seen LCR meter? Raise up your hand. You have seen it during IPT. Alice, haven't you seen it at workplace in Tanesco? You're not using that. Oh, you're not sure. You're not in that department, eh? Okay, well. Say LCR meter. Yes. L standing for inductance. Say inductance. And C stands for capacitance. Say capacitance. And R stands for resistance. Say resistance. So this is the instrument. It's integrated. Stop writing. Stop writing. This is an instrument which can measure inductance of the inductor, capacitance of the capacitor, and resistance of the resistor. So it's integrated, right? These we call them passive electrical components. Do you agree? What the difference between passive and the active. Until we review, eh? Number 60. Number 60 is called the spectrum analyzer. Say spectrum analyzer. Say spectrum analyzer. Yeah, so this is the electronics measuring instrument that actual, but you used to have spectrum analyzer. Do you have audio recorder? Do you have audio recorder? Na software ile ya kurekodi sauti wakati mwingine sauti ikirekodiwa tunaona vitu vinapanda vinashuka. Ile ndio spectrum. Ina analyze sauti. Kwa hiyo ukiongeza inaenda juu, ukipunguza manake ile ni amplitude against the frequency. So this is the one of the instrument that we are using for that purpose, spectrum analyzer. Then the another one is called the signal analyzer. Say signal analyzer. Then another electronics and electrical measuring instrument, number 8, is called the frequency. So this one is analyzing the signal, and this number 8 is called the frequency counter. Frequency counter. Say frequency counter. Frequency counter. Then another one, this is important for electrical engineer. It's called what? Clamp meter. Say clamp meter. Do you know clamp meter? How many of you have seen clamp meter? So some students have seen clamp meter. Very good. So who can come with it next Friday? This Friday? So that we may see. Hope. Will you come with it, Mr. Khan? Oh, you left it. Johari, so Johari will come with a clamp meter in the next class. Another one, we need at least 2. Johari, will you come with it? Johari said that, no, I'm not the one who said that I will come with it. Okay, so this is clamp meter. It's used to measure current. And the principal operations by using electromagnetic field. Whenever there's a flow of current, there's a magnetic field. So this one, it's an ammeter. It contains an ammeter, but it's not connected direct to the wire, but it will actually measure the current flowing through the conductor without the physical contact. Okay? Do you remember our gripping rule? Do you remember about the electromagnetic induction? That's all about the principle that should be used. Number 10. Number 10 is called the thermometer. Hey, this is common. And most of the students, they used to have it. Thermometer. And for the thermometer, we have 2 types of thermometer. There is a digital or infrared. Good evening. Good evening, students. How are you? You're welcome. Okay, so say thermometer. Most of the students in this class only automatic car. And automatic car has a dashboard. And on that dashboard, one of the instruments which is there is what? Thermometer or thermostat. Do you know about thermostat? Yeah, so thermostat. So it means within your car, there's a digital what? Thermometer. Okay? So this is the very important measuring instrument when in case of the industries. When you visit any instrumentation departments, you'll find industrial what? Thermometers. Then number 11, it's called the voltage tester. Say voltage tester. Say voltage tester. So this is also a kind of electrical measuring instrument. It's a testing instrument, right? So we'll discuss it. How does it work? Number 12, it's called the bridge circuit. Bridge circuit or Whetstone bridge. Whetstone bridge. So bridge circuit, say bridge circuit. Say Whetstone bridge. Yeah, do you remember Whetstone? It is practicals of electrical during secondary education. Wow. Whetstone bridge. Then number 13 is called the insulation resistor tester, or this is the electrical measuring instrument. It's called the megiohmmeter. Megiohmmeter. Class say megiohmmeter. Again, Emmanuel is not saying. Mega, where is mega? Megiohmmeter. Okay? Say megiohmmeter. So then we have insulation resistance tester. So we call it a megiohmmeter or insulation resistance tester. Okay? Say megiohmmeter. Or we call it insulation resistance tester. These are the electrical measuring instruments we are using oftenly in high tension. Okay? In high tension. Then number 14, we call it a digital logic analyzer. Digital logic analyzer. Say digital logic analyzer. Kanje yourself, say digital logic analyzer. I said Kanje. We have only one Kanje. But we had more than one Kanje. So Kanje, it means that you have supporters. Yes, so you have to make sure that you be a contester of 2025. Because you have some people who will support you. Then number 15 is called the electronics load. Say electronics load. Some of these measuring instruments and testing instruments are new for you. But it's better to have an idea because you may encounter them in different applications, including what? Interview or practical interview. Number 16, we have almost 50 measuring instruments in electronics. But I just say, let me expose you. The curriculum asks me to expose you for at least 10 measuring instruments. So number 16 is called the counter timer. Say counter timer. Say counter timer. Okay, so I said from the beginnings of this program, I have different techniques of teaching adult students, teenager students, and sometimes I used to teach children of 6 years, etc. So for the adult students, I know that I use the trick of reinforce the understanding. It means to write something in your mind. So if you're interested, you will follow me. If you're not interested, you can keep quiet, okay? But let us reinforce our understanding about that list. We don't want to go and read again. We just want to write in our mind, and then during exams, we may remind ourselves quickly, and then we move. So class say multimeter, power supply, signal or functional generator, oscilloscope, LCR meter, spectrum analyzer, signal analyzer, frequency counter, clamp meter, thermometer or digital or infrared, voltage tester, bridge circuit or Wheatstone bridge, megiohmmeter or insulation resistance tester, digital logic analyzer, electronics load, counter timer. So ask your neighbor, which one do you like among the 16? Among the 16 measuring instruments, which one? Megiohmmeter? Multimeter. Others multimeter. Who likes signal analyzer? None, eh? Okay, so after listening, for you have to make sure that you find number 17, number 18, number 19. Because any teacher who loves his or her students will leave a simple task to his students. So just add the 4. Then, so after mentioning, let us discuss in brief. And the special will be focused about its principle of operation and its function. What does it measure and how does it measure? So we are not going. So in this topic, we are not going to get into detail of the particular measuring instrument. But in this topic, we are going to give you overview. For instance, voltage tester. What is it? How does it work? And what does it measure? That's all. Okay? But we cannot draw maybe this is the voltage tester and whatever. So in case that maybe we want to discuss one of the measuring instruments, we'll go into much details that we have. We'll just discuss, then categorize. Is it analog? Is it digital? We have analog version, digital version. That's all. Okay? Class, are we together? Well, so then let us start with number one, the common one. I will bring you because you say you like a megaohmmeter. So today we'll discuss this, right? Yeah, so at least you say, wonderful. And the LCR-meter. Do you like LCR-meter? No, you say no. You're electric engineers. You don't like inductor, resistor, capacitor. That's all about electrical. Inductor, capacitor, resistance. Okay, multimeter. Say multimeter. So simply say that a multimeter is the electronics measuring instruments, if it will be asked to define measuring instruments that consist multiple measuring and measuring and testing instruments. Testing instruments. So that contain multiple measuring and testing instruments. So for measuring instruments to measure differently, to measure and test different electrical, physical quantities. So we say that a multimeter is electronics measuring and testing instruments. That consists in multiple measuring and testing instruments to measure and to test different electrical, physical quantities. So different multimeters contains different multiple measuring instruments. We have small size, we call them small multimeters and large multimeters, which consist a number of the instruments. Then basically types of multimeters. Multimeters. So we say that in electronics there is two types of multimeter. The first one, so there are only two types according to the functionality or the structure. Two types of multimeter. The first one is called the analog multimeter. Say analog multimeter. And the second one is called the digital multimeter. So you have analog multimeter, analog multimeter and digital multimeter. So what the difference between analog multimeter? Well, we discussed it and I showed you, but let us just write in short. So you say that analog multimeter, and we saw it in W15.2. Analog multimeter, we say that uses a needle, and the Emma was the one who was telling us that is analog and the digital. Uses a needle and the scale. So needle and the scale to display the measured to display the measured electrical physical quantity. Physical quantity. So analog multimeter, this is the electronics instrument that uses needle and the scale to display the measured electrical physical quantity. And in most cases, analog multimeter consists its structure or architecture. It consists a number of analog circuits. Analog circuits. So we differentiate analog multimeter and digital multimeter according to how they display the reading. So when you talk about the scale, just to expose you, this is the scale. And then you find that this is the one of the line. You have a photo of it. You may preview it right now and refine it. And then for this case, let's say there is a needle. So in this scale, let's say that here we have 0, here you have 1, here you have 2, we have 3, we have 4, we have 5. But I think that they should be in descending. So this is 0, and here we have 1, 2, 3, 4, 5, 6, 7. Let's say that this is a voltmeter. Then for this side we have 0, 1, 2, 3, 4, 5, 6. So this is the needle. Say needle. And this is the scale. So this one is ammeter. This is ammeter. So with this one also you have another scale. You can find that this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And here we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So suppose that this is voltmeter and this is ammeter. Stop writing. Stop writing. In previous workshop, practical workshop, we did not discuss in detail about this scale. Listen, listen, listen. So this is the center. 0 is the center, right? And we have a scale on right hand side of 0 and left hand side of 0. Why? Because in measurements we always have positive values and negative values. So when the needle deflects this side, then it will give you the positive reading. When deflecting in anti-clockwise, then it will give you negative reading, but within the same measuring instrument. So this, the first scale, this one, the middle scale, is a voltmeter, scale for voltmeter, right? Then the other scales is a scale for ammeter. Are we together? You can review the photo. Emmanuel has it. Where the photo? Emmanuel has a number of phones. Refer the photo of the analog voltmeter, multimeter that you have taken or you have discussed in previous class. So this is, we call it figure 1. So the scale and the needle of analog multimeter. Then number 2, digital multimeter. So remember that according to the developments of the digital multimeters, you could ask yourself a question. If there is a discovery of digital multimeter, why do we still have analog? Stop writing, please. So this is the exercise today. Wonderful, very wonderful. If we have digital, you know that digital always is simple, interactable, efficient. you know that digital instruments or whatever that called digital is real digital, right? So if you have digital multimeter, why do you still need analog multimeter? Ask your neighbor. If you have digital multimeter, why didn't digital multimeter phase out analog multimeter? If you want to discuss that question, I will ask you in exam. So please discuss it. Digital instruments always, or digital electronic system always are efficient more than analog, right? So we said that we have analog multimeter. This is the first one. The first type of multimeter, the oldest one, just like you yourself. The veteran of multimeter is analog multimeter. So this is the modern one, teenager, a young guy. But this is working efficiently more than this. But why do we still have analog? So you say that a digital multimeter provides readings of electrical quantity. Provide readings of electrical quantities. In very good numerical form by using digital display called what? LCD. So we say that a digital multimeter provides readings or measured physical quantities in numerical form by using what? Digital display. In bracket, we call it liquid crystal display or LCD. Are you together? Sign here. Because I think that you said that the attendance is full. Good evening. Good evening. How are you? You're welcome. So a digital multimeter, it displayed the reading by using a digital display or liquid crystal display. Okay? And actually this display uses 8 diodes to display the physical quantity. Okay? So this is the first diode, second, third, fourth. Then we have fifth. Then we have sixth. It uses 7 diodes. So for instance, this is 84. 1. Then 2. There's no gap here. 3. And then 1. Then 4. 2. So this is the digital, this is the display. Display to display the what? The physical quantity. So the display of what? Of digital multimeter. So what did you find in that question I asked you that? If you have digital multimeter and they have analog multimeter, and digital multimeter is most efficient rather than analog multimeter. Brother, you have just came right now and then you are signing. Did you come for the purpose of signing? You could even give your friend and then you are signing for somebody. You are signing for yourself? Yes. Bongo man. So the difference between, one of the external difference between analog voltmeter analog multimeter and digital multimeter is the way they provide what readings. Okay? Yeah. So, let me give you a response. If you have digital multimeters, why didn't digital multimeters phase out analog multimeters? That's the question, right? So what did you find? Nothing, This is the response. Analog multimeters are still used in electronics and electrical measurement or measuring because they have a good sensitivity rather than digital multimeters. So the matter is what sensitivity. And when we talk about sensitivity, we means that you can find its sensitivity is 0.01 voltage, while maybe digital measuring instruments cannot give you that sensitivity. Okay? So in engineering, especially that postgraduate level or research engineering, sensitivity matter. Just see simple and fundamental engineering sensitivity might matter or something might not matter. Class, are we together? Is it clear? What are the applications of multimeter? Applications of multimeter. Applications of multimeter. Please mention to me applications of multimeter. We are using multimeters to do what? Ima, the first application of multimeter is what? To test the continuity. Very good. To test the continuity. Continuity between 2 points. Between 2 points. Kanje, the second application of multimeter. To measure voltage. Which type of voltage? To measure DC voltage. So multimeter can measure DC what? DC voltage. Say DC voltage. Number 3, hope. They say the functions of multimeter. To measure which type of current? AC current. So multimeter, it measure what? Measure AC current. Kaundime, application number 4 of multimeter. To measure resistance. To measure what? Resistance. Number 5. Then my friend there who came right now, the 5th application of multimeter is what? He said that. Madam, the 5th application of multimeter is what? To measure AC voltage. To measure what? AC voltage. Number 6, Johari, the 6th application of multimeter is? They've mentioned all of them. No, they're still there. Number 6, who can tell us the 6th application of multimeter? We still have a number. To measure? To measure transistor. Okay, good try. But actually to test the transistor. Or to measure DC. Okay, to test the transistor. But we can just see, okay, we can, if in case of the measurement, to measure DC gain. So to measure DC gain. DC gain of 40 of BJT transistor. Number 7, again, Emmanuel. To measure the capacitance of the capacitor. Very good. So to measure what? So transistor or what? Multimeter, it can measure capacitance of what? Of the capacitor. Number 8, Countryman's neighbor. What's your name? Vanessa. Vanessa, number 8. To measure what? Vanessa. Vanessa is saying that all of these have been mentioned. No, there's a number of. To measure what? Frequency. Very good. So it can measure what? Measure what? Frequency. Frequency of, yes, frequency of AC signal. Frequency of AC signal. Number 9. If you had mentioned 10, in exam I will ask you to mention 20 applications of multimeter. Yes. Alice, number 9. To measure what, my friend? Are you in class or you are still out? You are in the class. Tell us, number 9 there. To measure what? It's already, he has mentioned. Alice? So Alice is discussing with her neighbor. Okay, number 9. Also, multimeter is used to measure AC voltage. AC what? Voltage. AC voltage. Where is AC voltage? No, that is DC voltage. This one, number 5, okay. Resistance? Ready. Well, so it's used to test. To test what? To test the diodes. Whether it's function or it does not function. If the potential drop across the diode is 0.5 volts or above, the diode is functioning or it's working. If it doesn't give you 0.5 as the potential barrier, then the diode is no longer functioning. Number 10, multimeter also is used to measure temperature. To measure what? Temperature. Yeah, temperature. Surrounding temperature. Yes. You haven't seen? Okay, come tomorrow, I will show you. It gives you surrounding temperature or room temperature in terms of centigrade or in terms of Fahrenheit. Do you remember how to convert centigrade into Fahrenheit? Do you remember that formula that's at the back of Umsomi exercise book? Okay, question about multimeter, a brief. You have overview of multimeter, right? Now the question is how you use multimeter to measure these physical quantities. And that question we have answered on how to read the user manual of that particular measuring instrument. Because in the user manual they explain how can you use that multimeter to measure voltage. How can you use that multimeter to measure DC voltage? How can you use that multimeter to measure AC resistance? So the manual gives you, train you about this. Are we together? Yeah, that's why I told you that it's better. It's very important for you to find the manual. So once you know, then if we give you electronic circuit, then you can test what you have been going through in that manual. Question about multimeter, brief discussion of multimeter. Simply we have analog, you have digital. In terms of digital, we have 2 types. We have auto digital multimeter and manual digital multimeters. And I've shown you. The difference is actually in case of manual, you do a lot of setting. In case of the digital, you just choose the instrument, that's all. Okay, class? Well, so if it's clear, then let me teach you another important measuring instrument, testing instrument actual. It's not a measuring testing instrument. And then we'll go to the one that you're interested, that is mega ohmmeter. Number 2 is called the power supply. Say power supply. Say power supply. Do you still have a photo of power supply? Can you review it? Check it. In power supply also we have analog and digital power supply. So let me teach you and then you'll tell me that whether that is analog or digital. So a power supply, we say that is the electronics testing instruments or workbench that provides DC power to the electronics system or circuit. So the main functions of power supply, hello madam, hello. The main function of the power supply is just to provide DC power. Say DC power. So simply a power supply works like a battery. The main function of the battery is just to provide what? DC power to your mobile phone. Okay? So but this power supply should be connected to the AC power. So within it is switching mode power supply, which is converting AC power into DC power. Are we together? So sometimes when you've designed your circuit, then you are interested to measure maybe resistance or whatever, or voltage or etc. But that circuit need power to work. So we are using this power supply to supply power into the circuit. Okay? For instance, you are learning about analog. Stop writing. You are learning about analog. Say analog electronics. Say analog electronics. Ask your neighbor, is analog beautiful? Yeah, somehow. So in analog, you are learning about the amplifier or bipolar junction transistor in terms of amplifier. So this one is collector, resistor, and then you are learning about the voltage divider. Isn't? Have you ever been learning about the voltage divider? Yes. You may say that I did not go through it, but this is the one of the circuit that you have to know. So then we say that this is the base of the transistor, this is the collector, this is emitter. And then we have another resistor, this is called R2, while here we have another resistor, this is called the RA. And then we have this one, this we call T ground. So then this is the point that you want to supply. We have coupling capacitors. I want to show you that how do we use power supply. That's all. That's my intention. So this is capacitor 1, this is capacitor 2, coupling capacitors. And here we have another capacitor which we call it bypass capacitor. I believe that you are familiar with something like this, either in A level or in analog electronics, isn't it? So stop writing. So practically, this VCC, in most cases, you use it to solve that VCC is 12 volt. Okay? This VCC, it's DC power. So we get this VCC from the power supply. Are we together? And then, here, we need to introduce what supply the signal, which is analog signal. This ground, this is positive of power supply, and this is the negative. Ground in electronics means that what is negative terminal, right? Right? It's not like the S in electrical engineering. In case of electronics, it's called the common ground. Say common ground. So this VCC, this is the point where we are using what is power supply. So we get this 12 volt or n amounts of the voltage from the power supply. And that's the use of the power supply to provide what provides DC power to the electronic system or what circuit. This is the electronic circuit. Are we together? Then we need the input. Remember that the main function of this DC supply into this circuit is actual to do what? Biasing. Say biasing. Say biasing. To bias what? A transistor to operate as an amplifier. Because a transistor can operate as amplifier, and also a transistor can operate as a switch. When it operates as a switch, you have something called the cutoff and the saturation point. Cutoff point is saturation point. Do you remember? And we discussed about load lines. Yeah, you have been good. For those who have come from A level, they remember about that. Then, so once you bias the transistor to operate in cutoff, in active region, right? Not saturation and cutoff, then you need to supply now the signal. You need this amplifier to amplify. And this signal, the input is signal, always, you used to draw that, you have analog signal, continuous signal. So this continuous signal will get it from the instrument that I've mentioned that called the signal or function generator. Signal or function what? Generator. Are we together? Yeah, so that's why that number 2, I'm teaching about power supply. Number 3, I will teach about signal generator. Number 4, I will teach about oscilloscope, because the oscilloscope which will show you the amplified signal. Oh yeah, oh yeah. Okay? Class, are we together? So if you don't have power supply, then the circuit will not get DC. And if you not get the DC, the transistor will not be biased. And if you not be biased, it means you don't have an amplifier. Class, are we together? So this is the testing instrument. Power supply is not used to measure. Jamani, power supply itumike kupima, eh? Usije ukaanza kutunga uongo kwenye mtihani. Haitumiki kufanyaje? Yenyewe inatumika kama bank, power bank, DC power bank. Kuipa nini? DC kwenye circuit. Are we together? Ndivyo ilivyo na pia signal nini? Signal function generator. Haitumiki kupima. Yenyewe inaipa signal circuit yako. Sasa hii signal ndio baadaye utakuja kutumia multimeter na oscilloscope kupima huko mbele. Are we together? So because I want to show you where we apply these measuring instruments, then on this side let me draw that we have, so we have what? We are going to have amplified version. So this is most amplified compared to this one. So for this case, in order to visualize the waveform, we need to use what? We need to use what, class? Say oscilloscope. We need to use what? Oscilloscope. So from there, you have noticed that this is the power supply, this is signal function generator, this is oscilloscope, but measuring the voltage, for instance, across R1, if you want to find voltage across R1, you'll be using DC voltmeter. If you want to measure the voltage across R2, which is VR2, you'll be using DC voltmeter. If you want to measure current, base current, you'll be using what? A milliammeter. Milliammeter. So this is another point. If you want to measure collector currents, then you'll be using milliammeter to measure what? Base current. Are we together? Yeah, so that's how we are using the 4 common measuring and testing instruments in electronics. So so for this case, we'll be using what? Multimeter to do the measurements of the different testing points. And here we are using signal generator to give us continuous what? Signal. And we're using the oscilloscope to visualize what? The waveforms. Okay? We're using the power supply to provide what? DC power. So this will be our figure 3. The schematic circuit diagram. Schematic circuit diagram of preamplifier. Preamplifier with measuring and the testing instruments. There? Pardon? DC power. But its input is AC. It's just like your mobile charger. It receives AC and give out DC. Why it gives DC? Because most electronic circuits, they use DC power. However, that sometimes we have AC power supply, but it's not common. Yeah, which takes input AC and output DC. AC. Okay? You didn't draw. What are you waiting? Huh? Emmanuel is not drawing. Emmanuel does not have a pencil, first of all, and then he is not drawing. Okay, so that is all about the power supply. That's what you need to know about power supply. So we have, yes, maybe one thing to discuss, types of power supply. We have 2 types of power supply in electrical and electronics engineering. The first one is analog. Say analog. Class A, analog. Analog power supply. And the second one is called the digital power supply. So remember the difference is how they give reading. They give out total reading. For analog, we are using, it uses what? A needle and a scale. Right? Digital uses what? LCD display to give us the numerical readings. Okay? So the power supply I showed you in W15.2, is it analog or digital? Refer the photo. The power supply, were you in that workshop, the practical class? No. This is your first time, eh? Second time. Third time. Oh, unknown times. Okay, so check, refer the photo of the power supply. You had, were you there? No. That one. So is that analog power supply or digital? Analog. Why? Because it has two scales. One scale display what? Voltage. Another scale display what? Current. So voltage is applied to the circuit and current is applied to the circuit. So it has a needle and scale. Okay, class? However, that the department, so when you go for the in our workshop, I will show you analog. I've shown you analog power supply. I will show you, and we'll be using digital power supply. So the digital power supply for this case does not use a LCD display. It uses 7 segment. Say 7 segment. Say 7 segment. So its display uses 7 segment. It's just like here. It displays the numbers as how you see in Mendokasi display. You see in Mendokasi display? Or in petrol stations. How many of you have been seeing the display of petrol station? A number of you, right? So that's how it displays. So it displays digits by using red color, which you call the 7 watt segment. So it uses LEDs, light emitting what? Diodes. It does not use what? LCD. Okay, class? Is it clear? Well, number 3, signal generator. Signal or function what? Generator. Signal or function generator. Class say signal or function generator. I again say signal function generator. So a signal generator, as we discussed it there, a signal or function generator, we say that generates various types of electric waveforms. Electric waveforms. So various types of electric waveforms, such as what? Sine signal or sinusoidal signal, square signal, triangular signal, or sawtooth. Class A is sinusoidal. Say sinusoidal. So this is sinusoidal signal. This is sinusoidal. It's a sine function. Means that the waveform, the nature of the waveform is sine function. It's a graph of sine, right? Then the second one is called the square. Say square. Say square. So square wave, it means a function generator can give these types of what? Of waveform. So this is what? Square wave. Then we say that it can also give triangular. So triangular waveform looks like this. And do you know that we have all of these waveforms, all these waveforms, we obtain them in Fourier series. This waveform, we find them by using mathematical model that called the Fourier series. Say Fourier series. Yes. Yeah, so Fourier series. For instance, this is the Fourier series of linear function. f of x is equal to x. Linear function should be defined from negative pi to positive pi. So if actual you make a non-periodic function to become a periodic function, you get a triangular what? Triangular signal. Okay? Okay, class? Look on the blackboard, please. Stop writing and stop drawing. Then we have sawtooth. Say sawtooth. So this is sawtooth. Sawtooth is look like a saw. Do you know a saw? Mnajua msumeno? Kwa hiyo hii waveform ilivyo ni kama msumeno ulivyo. We used to say that the law is just like a saw, It cuts both sides, isn't it? So this is what is sawtooth. So this is figure what is, student? Figure 4. The square, triangular, and a sawtooth waveform. But also you have sinusoidal. Let us draw sinusoidal because you may be expert with this new waveform, but you failed the common one that you've been discussing or you've been learning in A level, especially with AC power. So this is sinusoidal. Sinusoidal. So the square wave, the square, triangular, sinusoidal, side. So the main function of signal function generator is just to provide what? To generate, to provide electric signal which has either a sine wave or square wave or triangular wave or sawtooth wave. That's all. So it means that a signal function generator is the input device. It's just like a power supply. So power supply is just a supply. Okay? Signal generator we are using as the input. For instance, for this case, if you are designing the audio bipolar junction amplifier, then you need a signal generator to give you electric signal that required to be what? Amplified. Class, are we together? Is it clear? Question about functional or signal generator. So in case of the signal function generator, we don't have analog and digital. Yes, there are analog and digital, and you have them. Emmanuel, do you have a question? No. Ask your friend. Does he have a question? Your neighbor. Emmanuel's neighbor. Is Emmanuel growing? So it's providing this one. Oh, I forgot. Add this word. At different frequency. Different frequencies. Different frequencies. So a signal generator provides electric signal of the different waveforms at different frequencies. So what are the key parameters measured? So key parameters of signal generator. Key parameters of the signal or functional generator. So the key parameters, important parameters, the first one which you have to set is called the amplitude. Say amplitude. Say amplitude. What is the amplitude according to wave? You remember, eh? Amplitude is what? Maximum segment, maximum displacement, or 40, cresty or trough, right? So this is the important parameter. Number two, it means if you'll be given a signal function generator, you have to set the amplitude of the signal. Where the amplitude of the signal? Look here. For instance, you might find that the amplitude of the signal, for this case, you've been asked that to set 20 millivolts. So you have to set the 20 millivolts. Okay? Okay, class? Another important parameter is frequency. Say frequency. You as the electrical engineer, you are familiar with 50 Hz. But let me tell you that in electronics engineering, we have up to 20 gigahertz. So in electronics engineering, we are dealing, especially when we are dealing with information signal, we have up to 20 gigahertz. Say 20 gigahertz. For instance, I think that you heard about radar. And most radars, we have military radar and civilians radar. So those radars, they can scan. For instance, a radar at Tanzania can scan the entire space of Tanzania. And when it scans, it actually sends a pass of almost 20 gigahertz to the distance or to the incoming target that we call maybe an aircraft. And then that signal or the pass will be reflected back. And then after it will be reflected back, the radar display the moving target, whether it's moving towards the Tanzania space, airspace, or away Tanzania airspace. Okay? So in electrical engineering, whether it's 11 kilovolt kV, or you're talking about 33 kV, or you're talking about 220 volt or 240 volt, you are, I believe that in terms of frequency, still 50 Hz, isn't it? So let me update you. In case of electronics, we have 1 kilohertz, we have 1 kilohertz, we have also 20 kilohertz, we have 20 kilohertz, we have 100 kilohertz, but this is, we call them high frequency signal but low voltage and low current, right? In electrical engineering, you have low frequency signal but high voltage and high current. Okay? In electronics, we have high frequency signal but low voltage. For instance, the voltage of most of these signals or the one which has 20 gigahertz, you may find few millivolts. Okay? Are we together, class? So it depends. Some of the functional generator can provide up to 1 gigahertz. So the signal at the 1 gigahertz. Remember that when you talk about frequency, we actually differentiate the number of cycles per second. Okay? So if you say that 20 gigahertz, how many cycles are completed in 1 second? 20 gigahertz is equal to how many hertz? Anyway, you are not familiar with the radar system because you are not working at the airport, you are not working at port, you are not working maybe in military places. Let us talk. I think that we are enjoying about 4G and 5G. Right? Even your mobile phones, when you turn on data, you might find that it's right 5G or 4G, right? So 5G or 4G, so let's say 4G. Most of us, we are using mobile phones that operate with 4 gigahertz, right? So how many cycles have been completed in 1 second with 4G? 4 gigahertz is equal to how many hertz? 4 million. This isn't. Giga means 60, right? Mega means, no, kilo means 3. Mega means 6. Giga means 9. So do you see the radio wave that actually emitted from your mobile phone and being received? You are receiving a radio wave which its frequency is 4 billion. Is this it? 4 billion Hz. You're wonderful. Can you convert it to money? What if somebody call you in 4 gigahertz and then it's being converted into money? Imethibitishwa, hope. Okay, another important parameter in signal generator is called the waveform type. Waveform what type. And another parameter is called the offset. Another important parameter is called the offset. Say offset. Offset. Say offset. Okay. So we say the types of function generator. Ima, you are no longer writing, not just drawing, even writing. So we have two types of function generator. The first one, analog function generator. The second one is called the digital function generator. So listen. Hello. Listen. The analog function generator does not have a scale and needle. It just has a normal interface. So to visualize the waveform of analog function generator, you have to use an oscilloscope. Let me repeat. I have taught you previously about analog measuring instrument and digital measuring instrument. So from the previous times we said that the analog instruments has a scale and the needle. So function or signal generator is exceptional with that principle. Why? Because a function or signal generator is not used to measure or to test. It's used to provide. So it does not have a scale. It means that it does neither have a scale nor a needle. So how can you see the amplitude that you have set, frequency and waveform? You need to connect the analog function generator with oscilloscope to visualize what we need to provide to the circuit. Class, are we together? Are we together? Yes. May I repeat lastly? Let me repeat lastly. We discussed about analog multimeter. We say that it uses what? A scale and needle. Right? We discussed about analog power supply. Then you say that it uses scale and needle to display the reading. But for the function generator, it does not have, or it doesn't have, it does have neither a scale nor a needle. So how are you going to use? You are going to use it effectively by connecting the analog function generator with oscilloscope to see the amplitude from the analog function generator, to see frequency from the analog function generator, to see waveform from the analog function generator. Class, are we together? Are we together? Yeah. So remember that I will ask you a little bit trick questions in this part. Differentiate analog function generator and analog multimeter. So it's simple. Based on how they operate. Okay? Or how they give us readings. Because for you as an electrical engineer, we are not teaching you to make the instruments or to manufacture the instrument. We are teaching you how to use them. That's why we are talking about how does it display the reading. How does it display the reading? So it means that, can you understand the readings which have been displayed? That's all. Okay? But we have also to learn how to make them. Are we together, class? Yeah. So it's just like in mathematics. We have pure mathematics and the applied mathematics. So the one who is applying is just needs some issues. The one who is pure, even thinking about the new mathematical equation. Okay, So after that, what are the functions or applications? Applications of function generator. Function generator. The first application, a function generator is used to test a circuit. It is used to test a circuit, to test an electronics circuit, an electronics or electrical circuit. Whenever you go even in electrical workshop, you'll find the function generator because it's common in electrical and the electronics, electrical circuits. Number two, a function generator is used to simulate signal. It is used to simulate the electric signal. Electric signal. Number three, a function generator also is used to provide the test signal. It provides test signal to the circuit or other measuring instrument. So separating. So we have three applications, main applications of function or signal generator. The first one is used to test an electronics or electric circuit. How does it test? It provides the particular waveform of the particular amplitude. Then it can test that circuit whether it's working or not working. For instance, you say I've designed my BJT amplifier, right? So if you want to test, you need the function generator. Are we together? But secondly, it's used to simulate the electrical signal. Say simulate. Remember that nowadays in modern age or modern electronics and electrical age, every electrical system and every electronic system firstly is made in the computer before it has been made or implemented in hardware. Okay? So use this to simulate, to test. Means we are using computers to test the electronics and electrical circuit before we implement them in hardware. So that the means of what? Simulation. Say simulation. Simulation simply is imitation. Say imitation. So we are imitating that within Emmanuel's computer. There's a BJT amplifier. Why really it's not there? Then number three, it provides test signal. Say test signal. To the circuit or other measuring what? Instruments. For instance, so let me explain this point. Listen, this point. For instance, you have oscilloscope. You have bought a new oscilloscope. Then you want to test it whether it's working or not. You may need a function generator. You set the particular, you set the properties of the signal that from the function generator, and you connect the function generator, you connect the outputs of the function generator with the input of this oscilloscope. Right? But remember, you have read the user manual for function generator and user manual for the oscilloscope. So because you read them, so you know that, for instance, if you have set a triangular or square wave of the particular amplitude, so what you have set in the function generator, we expect it to get it in the oscilloscope. So that's why we say that it can provide a test signal to the other measuring what? Instruments or as a testing what? Instrument. Oscilloscope, okay, it has a default. It has a default signal. It has a default signal of the 1 kilohertz, but sometimes that default signal might be working, but it cannot receive the output from other parts. So rather than testing the oscilloscope by using the circuit, you may use the common testing instrument that called the functional or signal generator. Are we together, class? Yes. Is it clear? Yes. Did you get something about multimeter, function generator, and power supply? Yes. He must say no. Yes. Kwa leo tena bado. Even if it has remained 2 seconds. Question? Yes. That the functional generator, digital function generator.
Digital inakuwa ina display parameters gani hapa?
Okay, so I hope you ask me a question about the digital function generator. Say digital function generator. I spoke about the analog function generator, but I did not speak anything about digital function generator. Simply that was Hope asking. She was making a follow-up, and then she said that, sir, you talk about analog, how about digital? Well, a digital function generator, first of all, it has a display. Say display. Say display. Display. That display, it can show the amplitude that you are setting. Emmanuel, concentrate. It can show the amplitude of the signal that you have set. It's the functional or the digital functional generator. Also, it can display what the frequency that you have set, and it can also show the waveform type. So the digital functional generator, it does not need to be connected with what oscilloscope to visualize its output. Why? Because it has its own what display. Are we together? Yeah. So don't think that I will ask you that I mentioned this function. No. I will ask you explanatory questions, and are the one that I'm presenting to you. Okay? For instance, what's the difference between analog function generator? Or mention 3 or 4. A function generator and the digital function generator. So if you have been listening what I was teaching you, then it's a simple question. And you have a photo of digital function generator. Check it. You have a photo of digital function generator. If you don't have it on a mobile phone, you didn't download even from your WhatsApp group of the class. Because one of the students sent on your WhatsApp group. Did you see it? No? You found the number of messages, 400. Okay, so let us discuss the last measuring instrument that's called oscilloscope, and then we end the class. Okay? Number 4. So it means that in lecture 2, we'll discuss about those electrical measuring instruments. LCR meter, clamp meter, and the ones meg ohmmeter, the favorite measuring instrument of Emmanuel, the CR of this class. Say oscilloscope. Say oscilloscope. Say oscilloscope. Yeah, you learned this in modern physics for those who have been going for A-level. Do you remember? Modern physics, the first topic called the electrons before quantum physics. Kaundi may say, yes, long time. Kaundi may say that long time ago. So an oscilloscope, because Emmanuel said that this is evident. Wonderful, do you see? Amazing students. An oscilloscope, you're only welcome. An oscilloscope is electronics instrument. This is the electronics instrument that is used to measure what? That is used to measure and visualize, to measure, visualize, display, display what? To measure and visualize or display, to measure, I forgot something here. To measure electric signal, and display or visualize what? Visualize the waveforms of electric signal. So an oscilloscope, simply this is the electronics instrument that is used to measure electric signal and visualize or display the waveform of electric signal as the function of voltage versus time, or we call it voltage versus time. Okay, so because this is the last T and they are kind of tired, let us reinforce understanding. Stop writing. But if you are not interested, keep quiet. You are not interested with this technique of reinforce, keep quiet. If you're interested, let us read. So 1, 2, 3, let us go. What is an oscilloscope? So it seems like you are not interested, all of you. Okay, an oscilloscope is an electronics instrument that is used to measure electric signal and visualize or display the waveforms of electric signal as the function of voltage versus time. So let us read together. 1, 2, 3, go. Very good. Hey. So it means that will be, what do you think? If you say voltage versus time, stop writing. Voltage will be in x-axis or y-axis? Huh? And time will be x-axis or y-axis? X-axis. Very good. That's very important. Then, how many types of oscilloscope do you think you have? 1. Do you see? Hima. Hima say 1. Why? Because Hima want to leave the class. Hima has an appointment somewhere. So we have types of oscilloscope. So we have 2 types of oscilloscope, right? There are 2 types of what? Of oscilloscope. Ask your neighbor, will you call your firstborn oscilloscope? Yes. Yeah, ask again your neighbor. I'm serious. My neighbor, will you call your firstborn oscilloscope? Yeah, in order to be good in electronics. Because he must say that he will call his firstborn megiohummeter. So megiohummeter Emmanuel. There are 2 types of oscilloscope. The first one is what? Analog. Do you like analog electronics? You are not sure. You are not sure. You are saying yes because Engineer Sula is not here. But he could say that. Wapi. Boss, you are making jokes. And you have also digital oscilloscope. So you have analog oscilloscope and digital and I have shown you in previous workshop. You have the photo of them. Open the photo of analog oscilloscope and digital oscilloscope while we are discussing them. You have the photo? Ima, did you share them in the group? Ima stayed away from his neighbor because his neighbor was investigating him if he was drawing or not drawing. So Ima said, let me neutralize. Okay, so the analog oscilloscope displays signals using, so the difference, listen, in case of oscilloscope now, hello, in case of what? So the difference between analog oscilloscope and digital oscilloscope, it's not about scale, needle, and LCD. The difference between analog oscilloscope and digital oscilloscope is just the type of the display. The analog oscilloscope displays the output by using cathode ray tube or CRT. And you know that CRT, how it works in all the televisions receivers, right? While the digital oscilloscope displays the reading by using LCD display. That's how. So you should not claim that analogy, you need the needle and the what? Scale. Are we together? Yes. So analog oscilloscope, we say that analog oscilloscope is the type of oscilloscope that display HC output here. Yes, let me write output because I heard a fantastic pronunciation of output. Output readings or measured HC output reading by using the cathode ray tube. We learned this one in O level physics and A level. Do you remember it? Yeah. Aha. How many voltage do we want for the SRT to display a signal? How many voltage does it want? Excitation. You forgot, eh? Until you review, eh? Okay. Do you remember TV Zachogo? Eh? Do you remember? Have you found them? Others are young. they did not find them. Did you find them? Others are just familiar with flat screen. Eh? Flat screen and so forth. How many inches? 52, eh? At home, eh? And your children enjoy a lot. And they master it more than the mother and the father. Mama, mama, to eat the station a cartoon. Okay, so this is using what? Cathode ray tube. So the waveform which will be displayed, listen, the difference is the quality of the waveform. First of all, listen, this analog oscilloscope, once it displays the waveform, you are supposed to know the scale and study the graph and count the number of boxes. Then, in case you want to know the amplitude of the waveform and frequency, you have to use the number of boxes which have been occupied by the graph. Then you convert it according to the scale. Did you understand? Yes. Did you understand? Let me repeat. I said, for the analog oscilloscope, in case you want to know amplitude of the signal, frequency, maybe, yes, because these are the two parameters. You want to know, you have to calculate. You have to, because you'll find that its screen will be like this one. Then you have boxes. You have boxes, square boxes. So this is the one box, this is another box, this is another box. Okay? So for instance, you have a sinusoidal. A sinusoidal, just like this one. You see? Huh? Eh? So how many boxes did this sinusoidal cover? 1, 2, 3, 4. It's just like in case you want to sign in Google or Yahoo Mail or whatever. They used to give you something to distinguish you from robot. And then you are asked to not to mark what there, maybe the motorcycle or the traffic light, etc. So you have 4 boxes, but there is a scale that maybe one scale or one division maybe is equal to 2 millivolt. Okay? So one division represents 1 square box. So for instance, here you have 4 square boxes. Or maybe you want to compute the amplitude. The amplitude is actual. You'll say that 1, 2. Right? So you say that 2 division is equal to how many volt? Similarly for the frequency. Are we together, class? So for the analog oscilloscope, there is the manual work. But for the digital, once you display the waveform, it gives you all the information, and even the one that you don't want. Digital is good, yeah? In case you want to understand, you are thinking about driving a manual car and automatic car. Which one is simple? Oh, none of them, because others are not drivers. For those who are drivers, driving manual and the auto, which one is simple? Auto, eh? Go. So digital oscilloscope, we say that is the type of oscilloscope. The type of oscilloscope that Display. Display what? It's what? It's output, yeah? It's output readings. Why they are saying that? Sir, ask us these questions in exams, is it? By using what? The LCD or liquid crystal what? Liquid crystal what? Liquid crystal what? Liquid crystal what? Liquid crystal what, class? Display. With advanced features. Advanced features. Advanced what? Features like measurements, storage, and analysis. So that is digital oscilloscope. It's the type IMA, right? As I will make a photo. Write down IMA. You are not in the class. You have shut down yourself because you have an appointment. So a digital oscilloscope is a type of oscilloscope that displays output readings by using the LCD display with advanced what or additional features. Say additional features. Like what? Measurements, storage, and what? Analysis. It means this digital oscilloscope, you can capture the waveform and take them from that digital oscilloscope by using a flash or external hard disk, and you can display or visualize them in your computer. Okay? But again, with digital oscilloscope, there is no manual calculations of scale, divisions, or whatever. Once you display the waveform, it shows the amplitude, it shows the root mean square voltage, it shows the average voltage, it shows the frequency, it shows all the important parameters of that electric physical quantity. Are we together? Yes. So check the analog oscilloscope and digital oscilloscope because you have them. Show me. Check them. Analog oscilloscope and digital oscilloscope. So the appearance of the display actually give you a difference. Do you see the analog oscilloscope? Yeah, so this is CRT. And digital? Madam, where's your analog oscilloscope? Vanessa. You don't have. It has been sent in your group. You haven't seen. Kaundime did not inform you, eh? Kaundime was sick by that time. Did you visit her when she was sick? To give her sorry? No, eh? Where is digital? That is analog. Digital? Yes, this is digital. So you see that the digital has a number of buttons. Class, did you understand what I've been teaching you? Yes. Did you get something? Yes. Sure? Yes. Yeah, so I would like to congratulate you, and I would like to thank God who have given me a chance to teach you. This is the end of lecture 1, and I would like to welcome you in lecture 2. So let me leave you the homework, not assignment, the homework. Go and read LSR meter, clamp meter, and meg ohm meter. Remember that you have instrument number 17, 18, 19, and what? 20. I said, read about LCR meter, read about clamp meter, and read about Mr. Emmanuel, or what? Meg ohm meter. Then we'll discuss them in the next lecture. So thank you very much. Congratulations. See you in the next lecture. We did not congratulate you. Okay. If also you are not interested, don't clap the hands. But we who are interested, because we want you to remove the stress. When you go out there, we'll meet other stress. We congratulate ourselves. 1, 2, 3. Hongera. Imara. Wow. In English, good, best, better. Wabariki Afrika, wabariki
baridi